Hey guys, welcome to my first video lesson. Alright, so the first question is show and explain a graph to correlate with the function of the amount of gas in a tank when a driver refills the tank on a drive across country. So as you can see, the starting point where my little pen is going is it shows the x-axis, which is the distance, and the y-axis, which is the gallons. It kind of starts out higher up because they have not gone in any distance, so they still have a tank of gas. Well, then it just starts a straight downward climb because it's going up in distance. And then it stops and just goes straight up, which is the gallons going up, but the distance being the same. And then, of course, he starts his drive again, and so it goes right back down. So the greater the distance, the less amount of gas you have, obviously. And that's what this graph is showing. So the next question is a graph to correlate with the height of an elevator stopping at each floor on the way up. And as you can see, the x-axis is the different floors, and the y-axis is the height the elevator goes. And my pen is following the graph, and it shows the x-axis going and stopping, y-axis going up, stopping, x-axis going up. So it shows that the x-axis and y-axis will go up on their own scale, but not on the others. So if the x-axis is going up, the y-axis are dormant, and vice versa. So this is a graph showing the height of a bouncing ball dropped from a table. And the x-axis is the distance the ball goes, while the y-axis is the height of the ball. And you can see it kind of starts out, the y-axis a little higher up because it starts out on a table, and then it arcs and goes down and keeps going like that, because as the distance gets greater, you can see the height of the ball getting less because it's losing the bounce to it, and it's slowly coming to a stop. So this shows the graph of a length of a shadow on a flagpole throughout a sunny day. So you can see the x-axis is the length that the shadow goes, and the y-axis is the height of the flagpole. And you can kind of see that the x-axis is longer than the y-axis because the length of the shadow is determined by the height of the flagpole. And it gets bigger than the flagpole actually is because the flagpole is closer to the sun. So both of them are as far as they can go on their axes, and the shadow is longer than the actual flagpole. So this problem is taking f of x equals 3x and using the functions 0, 1, 2, and 3 to plug into the equation. Then they're using g of x, which is g of f of x equals f of x plus 8. So it's taking the answer from f of x equals 3x and adding 8 to it. So the blue line on the graph is the base numbers. The orange line is f of x equals 3x, and the gray line is g of x. And you can see that when the orange line is 0, or 3, the gray line is going up in 8. So the gray line would be 8 when the orange line is 0. And the blue line, because it is the base number, is triple, the orange line is triple the blue line because it's multiplied by 3 in the function. And then here we are taking 2 points and finding the slope of the line. So the equation for the slope is y equals mx plus b, or slope equals rise over run, which is how far the first point goes up and over to the next point. So you have the change in y, which is rise, is plus 4, and the change of x, which is run is +2. Divide that and you get 2. So our slope of these 2 points is 2. So we're determining the slopes of the line segments determined by the given pair of points, just like the last one. But unlike the last one, this line has the same x values, which makes it just a vertical line. When a vertical line, it's undefined. It does not have a slope because there is no run to the points. So it's just a vertical line that's got no slope to it. Okay, we're doing the same thing on this one. Our 2 points are -1, -4, and -4, -13. So you can see the points go up +9 and go over +3. So divide that, and our slope is 3. So for this one, you show and explain the graph each of the following functions and describe the similarities and differences in relationships between the graphs. So you have these 3 problems and made into a parabola, which is the curved line on the graph. And you can see the vertex is pointed towards the bottom, so it would have an absolute minimum, not a maximum. And the 3 lines, they kind of correspond because they're exactly the same, but their different points make them just a little bit higher than the other, which means they're not going to touch, they're parallel. So now we have show and explain the equation of the line through the given point that is perpendicular to the given line. So our first line is the blue line, and our perpendicular line is the orange line. So you have to find a perpendicular slope. The first line is y equals -3/4 x plus 5. So the perpendicular slope is going to be the opposite reciprocal, which would be 4/3 x. And then you take the different points. So you have 6, -1 as your point that's given, and you use that to get the y-intercept, which is -9. So we're doing the same thing on this question. Our first equation is -9. Well, our first equation was 2y plus 9x minus 5 equals 0. So obviously we have to get that into slope-intercept form, and we have to get the y by itself. So once you get the y by itself, you get y equals -9/2 x plus 5/2. And so using the point that the question gave us is 0, 3, and you can see I did the math over there. You get y minus 3 equals 9/2 times x minus 0, which is just 0. So then you have to get the 3 by itself, so you end up with y equals 2/9 x plus 3 as our perpendicular line. So on this one, you're finding the tangent line of the radius of 9 at 0, 9, and 9, 0. So you can see I have the different points labeled, and I'm writing it now, obviously. 9, 0, 0, 9, -9, 0, and 0, -9. And the 2 different tangent lines are on the top and the bottom at 9, 0, and -9, 0. Okay, so we have the different radiuses. One is at should be 0, -9 on the side right there, and the other one is -9, 0. So they look like they kind of cross each other because they're at the points that are next to each other on the circle. And all right, Well, thank you for watching, guys. I'll see you next video.